Hello and welcome. This is Subproject 3 and 4. Just want to cover what they are really quick. Right there we have Subproject 3 to the LCD screen. And then Subproject 4 I'm changing a little bit. It says the robot must make a sound. But I am doing a little bit different project than everyone else. So I am, for that one, going to cover the installation of Eclipse, Android app, how I got it to hook up with my phone, and some apps that I found online that pertain to this robot, and basically basics of Java, or basics of Android programming. So let's just go ahead and jump right into the first one. We're going to go into, this is the code for the print LCD screen. I did get some of it off of Pololu's website, but I changed it a lot, made it my own, everything, so that I know what I'm doing. I did want to show that I did build it with zero warnings. And now we're going to go to the robot. I'm turn on the flash here, a little bright, but yeah, there the robot is. And so when I press this button, or any of these buttons actually, it should print hello, wait for 2 seconds, and then print the millivoltage of the batteries along with waiting underneath. So hello, boom, there's the millivoltage. And it printing waiting on the bottom. The reason I did that was to show that I knew how to print to this top, the top, and then to this side. It's pretty easy from Pololu because it's just the LCD underscore go to underscore XY. Parentheses 0, 1 close parentheses. It's pretty easy. What I thought was more intriguing, turn off my camera, is Eclipse. This is Eclipse. I downloaded it from their website, eclipse.org if I'm not mistaken, and then you can go to android.com, go down to the bottom of the on the bottom development, and then download the Android SDK, which is the standard development kit. After that, you go up here to project. Click on the right thing. Well, it's right in there in the properties. It won't let me do it right now because I don't have a project up. But and you can configure that out, or you can also, I figured this out later, go to, where's it at? Search, project, run. Where's it at? Oh, right here. Install new software. That will allow you to download and install the Android SDK. See, on mine I already have it, so if I just want to, if I want to get more stuff or download a new one of the other SDKs, because there's a bunch of them, and it goes off the different API levels. Where's it at? Where's this stupid SDK at? There. Underneath Window, I go down here to Android SDK Manager, and I pop that open, and it'll load up and everything. And then you'll get this little window that's going to pop up right here. Any second now. Boom. And it has all the different SDKs. The newest one is API 17, which is Android 4.2. But what I'm working in is this one right here, Android 2.33. That works on about 97% of phones. Only, oh, come on, I don't want that, stop. Only about 7% of phones, I believe, have any of these, which means that 97 or so percent run on all of these. So if you use that one, you're basically hitting 97% of phones. It's also known as Gingerbread, API 10. So let's jump into some of these programs. This first one, the first one I found and used was this Shaker app. Pop up in its main.java. That's just this main file. This would be like your main C file. You have all this stuff. I'll go over it a little bit. This main class right here would be like your int main void. It's basically where everything runs in. You have a bunch of different things down here. What I think is really cool about this is you can leave that main. So we'll cover this at override right here. this will override the main activity if it happens. So public void on sensor changed. What that means is if one of my sensors changed, which in this case it's sensor event, and we can go up here, and that event, this event right here, is actually this event, right, where's it at, right here, in accelerometer, in sensor manager. And that is where we're getting this sensor event from. Yeah. Right there. You can see sensor manager right there. Oh, yeah. So, on that sensor change, when the accelerometer changed, it's going to run through all this stuff every time. So, as soon as I tilt my phone like I'm doing now, it's going to change that event, it's going to go to this add override, and then it's going to run this. We can go over this right here. So we got this float X, Y, and Z. That's your X, Y, and Z plane. Back up just a little bit. It's X, Y, and Z. That's your X, Y, and Z. And this is the code that it uses. This dot values right there is directly corresponded to the dot values of the X coordinate on my accelerometer in my phone. And it's 0. Value 0 is the X coordinate on my phone. Values 1 is the Y, and values 2 is the Z. Up here, I guess I'll cover that, is the text view. It was important. I was having a lot of failures because I was using edit text. Edit text doesn't work. You have to use the text view field, which I can pull up and show in the main XML. This is basically the graphical layout for this. You can see what it looks like on the phone. This is actually what it looks like on my phone screen. And then you can go over here. This is basically the code for all of that, it in code form instead of a graphical view. So you see here they're using text views, table layout, and then text views to display that information. An edit text field won't work. You can't push text into an edit text field. You can only type or something like that in these fields. But let's go back to the main now. So on every change of that sensor, the first thing it does is it checks to see, well, it does this, it runs this, and then it checks to see if minitialize is true. And I actually took this out. It was really annoying because every time the sensor changed, as soon as it stopped changing, it would change all the values in the field to 0, which is really annoying because I wanted to be able to hold the values there. So I took that out. And I changed down here instead of to print to XX, YY, and ZZ. I changed up here, going back up, I changed XX is the integer of X, YY is the integer I'm casting here, the integer of Y minus 9, and Z is the integer of Z. I casted those so I could get whole values. They were coming out in decimal stuff, and then right in here I subtracted 9 because that is actually the pull of gravity on my phone. If I do this, this will actually change Y to a 0 value instead of being at around -9, or I'm sorry, +9, because it's Y in your accelerometer. It actually does your change minus -9.8, which is the pull of gravity. Really cool there. And then this down here just takes care of printing all the variables. And after I was done, if I could run it for you and show you, it would just hold the values until I changed the phone, which is really nice. It allows you to see, like, I'm going to turn the phone sideways. When the phone's like this, basically everything is at 0. And then when I tilt forward like I am now, Z will change. Backwards, Z will go negative. To the left, X will go negative, and then it will go positive to the right, and then Y only changes when you shake like this. It's really, really neat little program showing how the accelerometer works. Now, I did find this nifty little program online. A guy did this already. This is not my work. This was done by some professors, I believe, at the University of Utah. But don't hold me to that. I think I read it was University of Utah. But basically, they took, and this SRC file is where all your main folders, or your .java, which is your main folders basically, is They took the 3Pi robot and built this app, and this app will transfer data to the 3Pi robot and send it back. It has the accelerometer control. That's the data manager. That's where they do that at. All of these control different things. Like you can voice control it. This right here actually takes care of. They have lights and LEDs and stuff. It would take care of that. And the Bluetooth service manager was turning on your Bluetooth, setting up the Bluetooth to be able to send data. Really, really neat. The only problem is they did the programming for the robot in Arduino, but it's not that big of a setback. I can convert the code to C. But yeah, it's going pretty well so far. I'm feeling a little bit more confident with Java programming now. It's actually not that hard once you get into it. But yeah, that's all for this project. I appreciate you watching. If you've made it all the way to here, we'll talk to you later, Steve.